Hello, folks. Welcome to Versatile DataKit community meeting. This meeting is here to inform the people who are curious using Versatile DataKit or just want to learn what it is. And yeah, I want to just say a quick reminder that Versatile DataKit is an open source project. And well, it's also used quite widely internally in VMware. So if any questions or comments that you have are connected to open source community, it's good. And like internal things, we can also take offline and discuss them there. And today on our topic is to discuss productionizing Jupyter Notebooks that Duigo was working on. So I would just invite some people who are in the team, maybe introduce yourself quickly, and then we can start with the agenda.
Okay, let me start. First time Stanley, Stanislav, working on VDK for quite some time and leading the team here at VMware.
Dugo, I think you are the only other person who is here.
Okay, so then I will just share my screen, I suppose. Give me just a second. So you should be seeing the PowerPoint screen. And me now. So hello again, and I'm Duygu. I'm a maintainer of Versatile DataKit. Been working for the Jupyter integration for a year and a half now. And yeah, you can contact me via these others here. And today I will be talking about the productionizing Jupyter Notebooks. So this is our agenda. We'll start with the quick introduction to Jupyter, then point out the main challenges with productionizing Jupyter Notebooks. Then we will do a short demo, and this is an overview of what we provide VDK as a solution for that. We'll do a short summary, and then it comes to Q&A. Or there are some messages in the chat. Okay, yeah. So I will really do a brief explanation of what Jupyter is, and if you are interested in why it is so popular, I have put here some blog posts that are interesting and explaining why it's so worldwide popular. So Jupyter is a versatile tool that just to work with data. It's a free platform that allows you to write code in and understand the data just with a few clicks within a file called notebook. We can consider it somehow like a playground for the whole data world. People typically use Jupyter to explore and analyze data. They write code in cells and run it immediately and see immediate results. They create visualizations easily, right alongside the code, and the format itself helps them a lot since they can include text that explains what is done and the results in it, the visualization, like it looks like this usually. And yeah, if you're more interested towards that topic, you can just check those blog posts, since it is not really the main topic of this meeting. The main topic is to point out the challenges in productionizing and how we solve it. And let's move. So as I mentioned, Jupyter has gained popularity with like formally for like its way of immediately showing what you write and the visualization, the whole experimental process of data. And now in the recent years, it's quickly making its steps into production environment, though there are some really big challenges towards that process. So the first challenge that I want to point out is the reproducibility problem, which comes from the nonlinear execution and hidden state risks. So notebooks allow nonlinear code execution, which can lead to hidden dependencies when cells are run out of order. We can see the examples in the first photo. So let's see that quickly. You can see that the first and the second section have the same output, but the third one has a different one. But we will start with the first and the second sections and what is different about them. So here it shows how the cells were executed. And as you can see here, you have 1, 2, 3, 4, which show that I executed this first, then this, and this, and got the output of 2. But here I don't have 1 and 2 and 3, and I just start with 4, which just shows that something was previously probably one of those cells were executed multiple times, but we do not know anything about what has happened. We just know that this was executed the 4th and this the 5th time, and this the 6th, and since the 6th time changes their values, the 7th execution will provide the same answer as here, since here we execute this right before the output again. But here, for difference, like here we execute, what we execute is like, we execute this first, then this, and A plus B the third, and we get a different output, which is 2 plus 3, 5, not 1 plus 1. And then after this, we execute this line. So you can easily see here that we have some hidden dependencies that cause different results. And here I have pointed out some more examples, like for instance here, we execute the same cell 2 times, but like we cannot really be sure that it was really executed as 2. And here, like we execute all the cells first and then change the second cell, and like we cannot directly see that it was changed, and it's really hard to understand what has happened. And here in the last picture, we just delete something and we totally forget about it. And if we come back in like 2 months and check it, we don't know what has happened. And yeah, this is one of the main problems, since, well, like this flexibility works amazing when we are experimenting with data. Like we write down random code, execute it, and in the end we get what we want and we are happy. But like when moving to production environment, this is causing a lot of problems, since there is no straightforward way to ensure that this stuff will be executed the same in that environment as it was executed in your local machine. Now let's move to the second challenge, which is with the version control of the notebooks. So notebooks are the version control of the notebooks can be complex, because like even though we see the notebooks like this in the UI, they are actually JSON formatted files, and they look like that. And imagine having a version control of this. It's just hard, because you get a lot of information that is not needed. For example, here I have just put it as section of the whole JSON file of an example notebook. Here you can see the whole schema, by the way. I have put a link. Here is the part of a cell that is a code cell that has been executed 2 times, and we get the last output of the cell. And here actually is the code that was executed. And actually for version control, we do not really need the output you got in your local machine. Like all this, for example, is unneeded because it's obviously going to be ignored. It's just a chunk of text that is populating space, and like whenever someone does a change, this will probably be changed too, and it just makes the version control really, really hard, since yeah, you get a lot of difference between one version and second version, but there might be just one line change in the source, but you will get all this stuff changed. And yeah, this is just an example. There are a lot other fields in the JSON as well. As I mentioned, you can check it out here. And let's move. The other challenge is linked to the irrelevant code. Like excessive irrelevant code, including unused print statements, unrelated snippets of code, hinder like Jupyter Notebooks readiness for production. Not like in Notebook, it's really common to include a mixture of code. The code, actual code, that is the algorithm you got for your data and how you transform it or ingest it and whatever it is. And the random print statements that are for quick debugging or checking your data, visualizing it. And all this is incredibly useful during development, since you get quick results, quick debugging and everything. But when we transition it to production, this patchwork of irrelevant code and become problematic. Like, you know, production environment demands clarity, efficiency, and reliability. Random print statements, temporary checks, or ad hoc code snippets can just like reduce your performance, and more importantly, can introduce some unpredicted behavior. So here I have put a really simple example of what is like, how it looks, the irrelevant code in a notebook. So here I just import requests and then request some data from API. And then I here check the response, like whether it's 200. Yes, it's 200. And okay, it's 200. Then I want payload to be like the JSON of that response, and then I need to check my payload, and I just print it. And all notebooks include stuff like that a lot. And as you can see, the actual code that is important is just this, this, and this. And those two cells are just irrelevant. And this is just a simple example. Of course, there are just many more complex use cases of that. So now comes the modularization. So most of the times, notebooks lack structure, and they grow bigger and bigger and more complex. And at some point, they just get really hard to manage as they get too big. Like splitting them into smaller modules is really, really hard, since there is no direct way to import stuff from one notebook to another notebook. And like you can do it yourself in one hacky way, but it's not really reliable that it would work in production. And or like some people do sections, like they just put some titles to the sections. Here I do transformation, here I do ingestion and stuff like that, but it's not a real modularization. So they really lack. They're just like a big piece of code that is being executed, and there is no direct way to modularize it. And the last problem is with testing. Unlike some other coding tools, like for Python, we have PyTest, for example, notebooks don't have a straightforward way to test the code within them. Like there in notebooks, generally there are no well-organized methods or functions. There is generally just a line of code that is being executed, and yeah, you don't have some tools, PyTest or libraries that just test notebooks. So testing all over is a big problem for notebooks, and yeah, this makes it a little bit problematic for production environment as well, since we want the code in production to be tested. And yeah, these are the main challenges I will point out today, since they are the most known ones. And now I will do an overview of our solution. I will actually do a demo of how we built a data job. Data job is a data workload, and data job is a specific name for VDK we use. And I will create a data job and then deploy it and just point out how we solve it during the demo, so you can see it live directly. Just let me share my other screen. I'm sorry. So here is my Jupyter lab, and what we're gonna do now is just create a VDK job. You can do it easily from the VDK menu that we have provided. And here we write the name of the job. Meeting. And I want it to be created in the exact place. And we get the message, job with name, demo job for Jupyter was created successfully, as our integration directly registers it in the control service, so in the cloud. We have an UI, and you can check it there. Demo job for Jupyter was registered as well. So since we do not have much time, I have already prepared a job for the demo, so we will go through it because it will take a lot of time for me to write it down. And let me explain what I want to do. So here I have some CSV data. What I want to do is to transform that data a little bit and then to ingest it into my database. So here is my Jupyter notebook. Oh, I'm sorry, I don't think it's the right one. I'm sorry, it's the other one. Okay, it's this one. So here is my job. And let's start with it. So here's my notebook. This is how they look generally. Here I have my CSV data again. And here we have requirements txt, which we use for our cloud like control service. They're not so important for this demo, so I will not go through them that much. So here in the notebook, the first cell we automatically get this cell by our integration. It is a cell that loads the job input variable, which is a special variable for VDK, which, let's say, makes it easy for you to work with your database. I will not go in details to it, so since it will take a lot of time. And this cell is just a configuration cell that loads that job input variable into your notebook so you can work freely with it. And let's execute it. It's executed, and now I have it. And so what I said, I have this data, and I want to do some stuff with it. I will use pandas to get the data as data frame. I use read CSV, and yeah, let's just run it. And now I want to check my data. Here it is. Let's see whether it's the same. Test user Mike 897. Test user Mike 897. It's the same. So what I want to do now is, as you see here, I have some test user here and here, and it is the data that we have put there. It's not actual data, it's just test data. So what I want to do first is to delete that data. Here, I will delete it like that. And let's check. Okay, it's not here. It's still here since we do not change the CSV, but we changed the data frame. So I have deleted it. Now I want to classify all the users. You see they have some kind of score, and according to that score, I want to classify them into the detractors, passives, promoters, or unknown if they have entered some random number that is not within the range. So I will define this function for classifying them, and here I will classify them. And now let's check again. Yeah, I have the new column with, which is like the classification includes what type is the user himself. You can see that a few times I have executed out of order. Like here is 6, where is 4? 4 is not present. Yeah, I have executed some stuff, as I have mentioned of the challenge before, out of order, but let's continue. So I have this data, and I want to, for some reason, let's imagine that maybe I have that table again, but with the data for the last month. Now I want to delete that table and just put the data for this month. I would just drop that table, which we do it easily with our job input variable. It returns what we have in that table, actually nothing. We can check again whether that table is present with this query. We run it, and here we get the exception that there is no such table. Let's just clear this output. And okay, I have dropped my table. I have seen that it is not present. Now let's create it and ingest our data. With our function send tabular data for ingestion, you can easily ingest it. I will just run it. It is run. And now let's check again. Yep, we have the data. And yay, I have done what I needed to done. And now let's see the problems here. So as you see, I executed this, then this again, then this again, and here I did it again and again, which is like out of order execution. And now what is going to be executed in the cloud when it is deployed? We can easily check it. I'm sorry. Here, I don't know whether you have noticed, but here we have like a different design on some cells, and not like some cells are just pale and have no tags or symbols or whatever. So with VDK, we have introduced VDK cells. Those are cells which include the VDK tag here. You can easily tag a cell with VDK tag like that and untag it. And what we actually do here is when we tag a cell, we say to VDK that this cell is going to be executed when it is deployed. Like here, for example, I don't really want this to be executed because it's just a check that I do of my data. It would like reduce my performance, and I don't really need it in the deployed version of the code. I just need this, the pandas. I need to read the CSV. I need to the function that classifies it. I need to delete some data. I need to add the column, but I don't really need the other stuff. Even this, the select, I don't really need to do it in the production environment, since it's just me checking whether it's done or not. It's just a print that is meaningless for the production environment. So in this way, we actually somehow solve the problem with the irrelevant code that is being executed in the production environment because of just doing checks and forgetting about them. And also, if you have noticed, I have some numbering on those VDK cells. This numbering is actually showing the user how the cells are going to be executed when they're put into production. So here you see it says this cell will be executed first, then this, and this. In this way, we are sure of how everything is going to be executed. And we also provide one function called VDK run, which runs the whole notebook, the whole data job, as it would be run executed in the production environment. So I already have that data. So now let's just delete it again. And we can check that it is deleted here. Let's clear outputs. Let's clear all outputs, actually. And yeah, let's just run VDK run. Okay, I'm already in the data job, so I get automatically the stuff provided. So here's a timer, how much the run takes. You can check the status. And yeah, the job was executed successfully. So the code is executed, and now let's see whether I have my data in my database. Yep, we have it, and it is like I have the additional column that I created. And actually, this shows us that actually the code that is tagged, that is in the VDK cells, does what it really needs to do in the production environment. Now, well, the job is ready. As I pointed out, in this way, we solve the reproducibility problem, and we are sure that everything, like the job, the code is executed the same way in your local machine and in the production environment. And also we solve the problem with the unneeded code that is also included in the notebook. And yeah, we all need to now just deploy the job, which is, you can do it again with the VDK menu, just clicking deploy. Some of the stuff are automatically locked, so I need a deployment reason. Demo for community, demo for community meetings. As you can see, we provide run data job before deployment here to, like, it's optional if the user wants to once again run it to be sure that it does exactly what he wants to do. And yeah, we can run it. We press OK. So right now it is running the job, and if it fails, it will not deploy it, and it will show an error message with the reason why it is failing. So in this way, we stop the code that is not working right from being deployed in production. But in this case, it works correctly and says the job was run complete. The job run was completed successfully. And here are some details about the deployment, which takes a little bit of time. But again, the user can come to the UI and check that it is deployed and scheduled. And yeah, now I see that there is some comment. So the connection, okay, what is the time? Okay, I can quickly show how it is for my database. We have different database plugins, so it is a little bit, it's almost the same for every plugin, but yeah, I will just show it quickly. Here we have a configuration file where we write down about the scheduling and yeah. And also here is a section called VDK. And here actually I put my database stuff. I use SQLite for this presentation. I have database default type, which is SQLite. Ingest method default ingestion works for SQLite. Ingest target default. This is the target table, like target database for my ingestion. And I have this file. So this is all I have to include for the database that I'm working now. We also have for databases like Postgres, Impala, and yeah, the documentation includes it. And actually, that's all. Like, this is all you have to do actually for the database. Here we have some options like you see context. We have the option notify on job failure user error, where you can put like your email address, and let's say after you put the job into deployment, and if it fails for some reason, you get an email about the failure. And here is the same for platform error, which is not your fault, but ours or some others. And yeah, this is all done in the configuration file. Okay, I will continue. So yeah, as I said, we deployed the data job. Let me think what I was mentioning before, because I wanted here to mention one more thing. Let me go back to. Please share us the link for the service. It looks like Databricks, but it is not. I'm sorry, but which service? Like, you can access VDK source code and see, try VDK from here. And like the stuff that I am showing right now is the integration with Jupyter, which is actually made as a plugin here called VDK Jupyter. And I will just leave it here. Yep. So yeah, I got my code deployed. And oh, about the version control. So if you remember here, for example, I don't know, I had like some stuff that were like outputs of my data job, of my code. And what we do here is, okay, you have those stuffs in your local machine, like you want to see your checks, you want to see your data, but we do not really deploy those stuff. So all those outputs and your check, this stuff and this are removed from the notebook JSON file. So it is easier to version control it, because like, imagine you just try some stuff and just, yeah, this is irrelevant for the production, let's say. And instead of head, you decide just to see all the data. And this, if we deployed the output as well, it would just like say that you did this change in your code, but actually like, and all this stuff, but actually it has no effect on the data job. Like it has no effect on what is being executed. And you would just go there, check all the stuff that has been changed for nothing. So for that reason, before deployment, we just delete all the outputs that you got in your local machine to be sure that while checking your code, your notebook, you do not need to check for stuff that are irrelevant. And for now, we are only deleting the output of the cells and the execution number and stuff like that. But as we are now doing usability testings, and after that words, we can receive some feedback that maybe some stuff should be removed as well. And if we have feedback that they should be removed as well for version control, we will be removing them too. But for now, we just remove the outputs that are irrelevant for the execution environment. And yeah, so we went through irrelevant code, we went through version control and nonlinear execution. Now comes the modularization. Okay. Let's move back to Jupyter. As I said, we cannot do direct imports in notebooks. What we provide here for modularization, let's clear all outputs, is that a data job in VDK can not only have one notebook, not only have notebook files as code that is executed, it also has SQL and Python code and Python files. Like I can easily here, let's say, create a new file, which I will call for now 10 the drop tables dot SQL. And here I will rename this as 20 notebook IPINB. And as you see, I get some data and I want to ingest it. And this drop table thing is kind of irrelevant. I can just copy this part and put it here and remove it from my notebook. And with VDK, when we run the whole job again, it would have the same output, since with VDK we support multiple files for one data job. And all we want is them to be sorted alphanumerically, which means like this starts with 10, then this will be executed first. This starts with 20, then this will be executed second. And like with this thing, I kind of like modularize a little bit the stuff that I have. Like I have my drop table thing out of the notebook. And also I just imagine that after this ingestion, I want to do some more transformation with that data from that table. I can easily create new notebook, which automatically is being created with this cell for the job input variable, and rename it, let's say, 30 transformation IPIND. And here I will get my job input again, get the data from the same database, transform it and do stuff in it. And like when you put it in production, the ingestion, which is here, will be executed first, and then this part will be executed second, and while you in your local machine can work on them fully separately. And in this way, you can kind of modularize your code. Like, you still cannot have direct imports from one IPIMB file to another IPIMB file, but you can modularize your logic. And also, as I said, we support Python files, which mean, like, in Jupyter Notebooks, you can import stuff from Python files, and yeah, it helps for modularization as well. And now let's go to the last problem, which is the testing. So here, for now, we do not have a direct solution for the testing problem in Jupyter Notebooks, but we have the initiative to work towards testing not only notebooks, but wholly, like data jobs being tested before deployment in a way that you can do it in Python, like with PyTest, and in TypeScript with Jest and stuff like that. We will work towards it. But what we provide now is, again, that run function. Since run function captures all the errors in the job itself, in the code itself, like, let's say if you here add some check, like after you select the data from here, it to include, let's say, that user blah 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 with that data, and like if it does not include, it will raise an exception, which we catch with the run function and show it to you. So it somehow solves the testing problem, because you get an exception and description of why it happened, but not directly. But we do have some plans on working towards that problem. And yeah, that is all about the demo, actually. And we can go back to the presentation and do a quick summary. So I show how with the numbering and VDK cells, we solve the problem of reproducibility, that we get what we have in the local machine in the production environment as well. With VDK, I show the version control, how we remove some stuff, and we can make it better with time if we get more feedback on it. I showed how we somehow get away with irrelevant code problem. Like, you can generally, even now, can delete cells and stuff like that, but it might cause you to delete something that does not need to be deleted and stuff like that. So it is a little bit more secure than just deleting your stuff, and you actually can have some stuff that you do not want to delete directly. Let me check the time. I hope I am not running out of time. No. So the modularization, I show it that you can modularize your logic, you can import some stuff from Python files, you can move some stuff to SQL files and everything. It is not direct, like we still do not support imports between notebooks, but it helps for the modularization. And lastly, for testing, I have put it in orange. We do not directly fully support it, but we do have some testing that is present. And yeah, now is the time for Q&A, and I'm open for questions if anyone has some questions. I hope that I did not forget something that I needed to mention. Yeah. Does anyone have some questions? So we have something. Oh, thank you. So for the Jupyter integration, we do have one more video on YouTube, but it's a little bit older. It's not as like the UI is just a little bit different since it was from months ago. And there I explain more about like the technical stuff. But we will soon add some tutorials on how to work with this into our GitHub. And yeah, for now, this is all, but we are going to add more demos and stuff, hopefully. And you can contact me whenever you want. We have a Slack channel also. Thanks.
I'm going to share the link to the video.
Yeah, I can stop.
Okay, so here goes. This is the previous community meeting. I'm sharing it now about the Jupyter integration. There is one more topic if there are no other questions. Anthony is going to share the latest release. Anthony, are you ready?
Yeah, it's during every community meeting we do a release where we just share what was developed in the open source project in the last month from the from the homepage of the projects. You can see all the releases starting by clicking release. So what are some of the major things of the 1.2 release? Actually, the first thing is, so I encourage you, if you go to the homepage back, you find out we have entirely redesigned it. Agita did a lot of the work. So basically now you have the homepage aims to be a bit more explaining what VDK provides and how you can use it, hopefully making it easier for people to get started. It goes through the VDK SDK and getting started workflow, where there's a short video about what VDK SDK is, then over data ingestion and how you can implement data ingestion one way in with Versatile Data Kit. Or I can just leave the video just for a second, for example. So this is just a brief overview of how you extract data sources. Then you can go over data transformation and similar things for deployment, operations monitoring, and of course the Lego-like extensibility provided with VDK, how you can use or build your own plugins. So I encourage you to take a look at it, and I hope it's a rather good introduction of Versatile Data Kit, or a reminder. Going back to the next things. So there are a couple of control service improvements. The control service is the is the part that takes care of actually running scheduling and running production jobs, making sure they are versioned and tracking lineage and so on. One of the things is operators. General control service is installed as a Helm chart in a Kubernetes cluster, and operators can have a lot of flexibility on controlling the environment in which user jobs run. And one thing that was added in last month was operators now can specify different images, Docker images basically, on which the data job run, and can specify how the data jobs are built against different versions, and how the system SDK which operators control is also built. Another thing that operators now can do is they have control over when a user, or let's say a data scientist writing in their own data job, decides to deploy the data jobs. Operator can control what files basically are allowed, either by extension or meme type. If file is not allowed, the deployment will fail. Alternatively, also another thing that was added last month is operators can also specify what files should be ignored. Some commonly ignored files are like the big files that are produced when Python is being built. If user accidentally tries to oppose it, the control cell will simply ignore it and not put it in source control. We are starting a new initiative, which is improving significantly the error handling and troubleshooting and development experience of VDK, particularly around logging, making sure that you are able to much easier track progress of data job executions, making sure that user logs stand out and operations traceable, and you can quickly, immediately see what was the problem. Currently, we are just starting with the initiative, so stay tuned for future updates on what we've done in future community meetings. We've added an overview. If somebody is more technically want to understand more technically about how Verstyle code is built, they can take a look at the architecture drill down at the architecture page. And finally, we have a couple of notebook UI improvements. Some of them you already see during the demo, like having a status bar where people can see what operations is currently progressing, how long time is taking, having a bit more visual elements about when there is a failure, like it's in red in Higgs and green. Also, if this is only required if you want to deploy a job, you need to authenticate or login, which now can happen with the login button in the. And finally, we have a new contributor, Max. Oh, I don't know if he's here, but he has developed a new integration for a database, DuckDB. DuckDB is a fairly lately popular analytics database, which can run entirely locally on your machine, similar to SQLite. And yeah, you can find out all the changes in the last month and everything. That was the short summary that I want to share. Thank you.
Thank you, Anthony. Okay, so we're really close to running out of time. I just want to say thank you to everyone who was here. All the community meetings are recorded and published on YouTube. If you just Google Versatile Datakit or you just open our repository, you can find in wiki page community meetings. And here usually we are announcing when is the next meeting, and also all the previous meetings and recordings are here with all the descriptions of the agenda of everything that we have done previously. Yep, the next meeting is going to be on 27th of September, the same time. And if you are here and you want to support us in the work that we're doing, please open this repository and give us a star. It helps greatly for us to become visible in the community. Yeah, thank you everyone and goodbye.
Thanks again a lot and bye.
Thank you. Bye.